All right. Hey, so let's do another example. Let's go top to bottom, the whole thing all at once. So cosine of theta equals 8 over 12. It says I'm supposed to use that given trig ratio to find the remaining 5 trig ratios. So I am, first of all, going to draw my graph walker. I'm going to label the angle. I could use the angle I just labeled, or if I wanted, I could have labeled up here. It's going to change my drawing, but there's no reason why you can't put theta in the upper corner. I just don't have as much room to draw a graph walker up there because there's words in the way. Okay, so cosine, that's adjacent over hypotenuse. So the adjacent is going to be 8, hypotenuse is 12. I need to find this missing side over here. So Pythagorean theorem says I have to do x squared plus 8 squared equals 12 squared, and that will be 64 equals 144. Subtract the 64, x squared equals 80. Square root both sides, x equals the square root of 80. So there's my opposite side. It's going to be radical 80. Or if you remember that you're supposed to always simplify radicals, we can simplify this. Again, WellMap is not going to mark you wrong if you leave it as radical 80, but if you want to have good mathematical practices, we're going to simplify radicals just like we always simplify fractions, right? Speaking of which, we could have actually simplified the fraction to begin with. We didn't. Let this be a lesson to you. Okay, so simplifying radicals. I know that 80 is, I don't write down the word saying things, I'm writing things. Okay, the square root of 80. That's the same thing as, if I break the 80 apart, the same thing as 16 times 5, because I know my weird times tables, including 16s. And once I see that 16 in there, I say, hey, I know how to do the square root of 16. The square root of 16 is 4. So I could have square root of 16 be 4 and just leave radical 5. So it's my opposite side. I can either say it's radical 80 or 4 times radical 5. Either one is correct. Either one will work. I'm not going to normally write them both down, but I just did. Okay, now that we have all the sides of the triangle labeled, we can create our ratios. Sine is, can we see everything? Sine is opposite over adjacent. So for radical 5, you could use radical 80 if you wanted. And the hypotenuse, I thought I had every side a different color, but I don't. The hypotenuse is 12. Let me go ahead and change the color of this one just so that I can have everything color-coded, because I like to have things color-coded. All right, cosine, that's adjacent, which is 8, over hypotenuse, which is 12. Tangent, that's opposite over adjacent. 4. Oh my gosh, radical 5. That radical sign almost got away from me. Over adjacent, that's 8. Okay, the reciprocal column, as long as I have named them appropriately, so I got sine, cosine, and tangent in that order, then I can name them cosecant, secant, and cotangent, which have abbreviations. I failed to mention that earlier. The abbreviations for the other, the 3 new trig ratios, cosecant is CSC, secant SEC, and cotangent is COT. All this stuff to remember. Mathematicians have something about 3 letters for abbreviations. So even like a 4-letter word like sine, it gets abbreviated to 3 letters, and then so does everything else. Like cosecant is a way longer word; it still goes to 3 letters. Strange. All right, fraction lines ahead of time. So one approach to finding cosecant would be to remember that cosecant is the hypotenuse over the opposite side. So I can look on my drawing to find the hypotenuse and the opposite side. A second approach would be to just do the reciprocal of sine. Either way, 12 is the hypotenuse in green, and for radical 5 is the opposite side. Okay, secant, that is the reciprocal of cosine, so I can put hypotenuse on the top and the adjacent side of 8 on the bottom. And I did mention we're supposed to reduce fractions. None of these fractions are reduced right now. Man, it's It's gnawing away at my soul. I'm just kidding. It actually doesn't bother me that much. Cotangent is the opposite, sorry, the adjacent on the top and the opposite on the bottom. So 8 goes on the top, and 4 radical 5 goes on the bottom. So all of these fractions can be reduced. Let's go back and reduce them all now. Okay. So the coefficient of 4 can be reduced with the 12. The radical 5, since it's inside a radical, that's a separate deal. We can't reduce it. But the 4 over 12, I can reduce that to 1 over 3. So I could call this radical 5 over 3. And cosine is 8 over 12. That can be reduced to, divided both by 4. That's 2/3. And for tangent, again, the radical 5, we can't touch that right now, but 4 and 8, that reduces to 1/2. I just call this radical 5 over 2. I don't need to write the 1 part as part of the 1/2. There's an invisible 1 on the radical 5. And then let's do the second column. Okay, the 12 and the 4, that reduces to 3. The radical 5, I can't do anything with, so it's going to stay, it's a radical 5. For secant, 12 over 8 is going to reduce to 3, to 3 over 2. I almost said it backwards. I said it right, and then I almost corrected myself to be wrong. All right, so cotangent, 8 over 4, that part I can reduce to just 2. And radical 5 on the bottom. All right, cool.